All right, let's move on to question number 8. All right, so question number 8 reads, if g of x is the inverse of f of x, what is the value of f of g of 2? Okay, so I'm going to first describe what the law is here, and then we will break it down and we'll try to understand how this law works. Okay, so if g of x is the equals to the f of inverse, so this is the notation um, of the inverse function. So we have a f to the power of negative 1 of x, right? So if g of x equals f of inverse of x, then the f of inverse of f of x is going to equal x. Okay, and why is this so? All right, so if we have a compositional function of a inverse function within a function, or a function within an inverse function, we're going to get x, and this is y. Okay. All right, so if I were to draw out a diagram here, so this is how functions usually work. Okay, so we have a group of values and we call this our domain. Okay, and we have a function, let's say f, that brings our values in this circle to a new set of values called our range. Okay, so the function is kind of like a bridge that connects or maps one value of in our domain to another value in our range. Okay, so the f of inverse takes values from our range and maps it back to a value in our domain, and it's going to be that same value. Okay, so the f of inverse just reverses whatever the function does. So you think about it like two locations, right? So you have home and you have work. So this is the transportation from home to work, and this is transportation from work to home, right? So let's say, for example, that we have a value a that's valid within our domain. It defines our function, okay? So that means a is mapped by f to be equal to, let's say, a value b in our range, okay? So if our function maps a to b, then our inverse function is going to take b and map it back to a, right? So how do I describe this? So maybe I should do something more like, sorry, I'll do it like this. So our function takes a and maps it to b. Then our inverse function takes b and maps it back to a. Now, another thing to note is that I described this before, but I'm going to describe it more in depth now, that the range of the original function is the domain of the inverse function, and the domain of the original function is the range of the inverse function. Okay, so that's something that we need to be aware of. Okay, so what does a compositional function do? Okay, so a compositional function takes the value or the range of the inside function and uses it as its domain, and it pops out a value itself. Okay, so let's say that in our example here that we have f of a, right? So we know that f of a equals to b, right? So our compositional function will then take f of b, we'll take b and pop out a different value. So let's say we are using this example, for example. So it does f of a equal to b, then f of inverse takes b and it pops out a different value, right? It pops out another value, right? But looking at our example here, if f of a equals to b, then so f of inverse uses b and it leads back to a, right? So this is why the f of inverse are the compositional function of f of inverse of f is equal to x, right? So we have a value x that leads to y, but then the inverse function is going to take that y and bring it back to x, okay? So in this case, we have in our example, we have g of x is the inverse of f of x, and we're trying to look for f of g of 2. Okay? So we don't really need to know what G function or F function is, right? Because we can use this law to help us find our answer. Okay? So G of 2, so let's say that we have this. So G of 2 brings 2 to something of value A. Alright? So we don't know what this value is, and we don't really care. Because once, so let's say, for example, that G of 2 brings it to, let's say, a value C. Okay? So now our function f is going to take value c and link it back to 2, because c and 2 are connected. So in this case, f of g of 2 is going to equal to 2, because g of 2 brought it back to a value in a domain of function f. That function f is just going to map it back to 2. Okay? So this is how this law works, and this is the rationale behind it. Okay? So other than that, this solution is correct, and you can move on.